Hi everyone, I'd like to share to all of you what is ANOVA and how to use ANOVA to do analysis on your result of experiment, alright? Okay, let me share the screen first. Alright. On ANOVA, the name is actually the analysis of variance, or we call it ANOVA. It used to do analysis of single factor experiments. Okay, before we learn on how to use ANOVA to do analysis, let's recap, let's have an overview what is actually designing an experiment. Okay, designing an experiment involves planning, organizing a control test to investigate the effect of one or more factors on a response. Okay, we have run many experiments since that we primary school, right? And I believe that every one of us understand what is experiment. Okay, experiment includes selecting the experimental units, choosing the level of factors, determining how data will be collected, and we will decide how the result will be analyzed. So here, ANOVA is one of the method that we can use to analyze the result. All right, so what are the importance of an experiment? Okay, if I give you chances to list out, I believe that you can list out a lot of benefit, a lot of advantages of doing experiment, right? So I just listed some of it here. First one is to identify cause and effect relationship, to optimize process or products, discover new insight, validate hypothesis, reduce uncertainty, and comply with standard or regulations. All right, next, what is single factor experiment? Maybe this is the first time you heard about single factor experiment. You hear these words, okay, single factor experiment. Don't worry. What is single factor experiment? Is a single factor experiment is designed to study the effect of one independent variable or factor on a dependent variable. Okay, there are a few terms that we need to understand on single factor experiments, where later we will use this term or these parameters in our ANOVA analysis. First one is factor. What is factor? Factor is the variable that is controlled or varied to observe its impact. For example, fertilizer type, teaching method, okay? Second one is levels or A. Okay, we note it as A, the categories or group within the factor. Example, fertilizer A, B, and C. Okay, the groups of each of the element that we study. That one is number of observation, N. Okay, we note it as N, where it refers to number of observation per group of the factor being studied. It represents how many data points or replicates are collected for each level of the factor. Fourth one is response variable. It is define the outcome being measured. Okay, for example, crop yield, student grades. All right, example, okay, there's a single factor experiment case here, testing 5 times the effect of 3 teaching methods on students' test score. So which one is factor, which one is level, which one is N, number of observation? Okay, let's look. The first one is factor. Factor here is the teaching method. So we are going to learn the effect of 3 teaching methods, right? So how many levels or A we have, or we call it A, the levels, we have A, B, and C, means that we have 3 levels, we have 3. And then we also have number of observation mentioned here, since that it tested 5 times. The testing is done 5 times. So number of observation N is 5, and response is the test score. All right. Now we will learn a bit, okay, the introduction of what is actually ANOVA or analysis of variant, okay. All right. All right. Okay. So ANOVA is the statistical method. Okay, statistical tool used to analyze data from single factor experiment that we learned in previous slide. Its purpose is to determine whether the means of the group level of the factor are significantly different based on the hypothesis that we have. Okay. All right. So there are a few types of ANOVA. First one is one-way ANOVA. So where we compare means of 3 or more group based on one independent variable. So we only have one independent variable and we will study or compare of 3 or more group. Okay. For example, do different diets affect weight loss? Okay. Second one is two-way ANOVA. We compare means based on two independent variables. Okay, two-way ANOVA, two independent variables. For example, how do diet and exercise influence weight loss? Okay, if we look at the first example that we have here, we only look at the diet. Okay, the independent variable is diet. Okay, the two-way ANOVA here, the independent variables diet and also exercise. All right. So, but in this video, I will show you only on one way ANOVA. And we also need to look at hypothesis testing because the ANOVA result very related to hypothesis testing. So the first one is we have H null and also H1, or sometimes we write it as HA. Okay, the hypothesis testing is equivalent to H null where there is no difference among treatment means, and H1 if there is significantly difference among treatment means. If the null hypothesis is true, changing the level of the factor has no effect on the mean response. All right, we finished the introduction part. This is the time for us to learn the ANOVA techniques to do analysis. All right. If you look at this, the table that we have here, we call it ANOVA table. These are the things that we should have in doing analysis using ANOVA. Okay, so the first column is source of variation where we have the treatment, we have error, and we have total. Okay, so you need to memorize this. Okay, for the source of variation, we have treatment, error, and total. Sum of square, later we will describe what sum of square, degree of freedoms. Okay, but now I just want to introduce to all of you the ANOVA table before we know what is the formula and also how to complete this table. All right. Okay. So in sum of square, for the treatment we have SS treatment. For error we have SS error, and for total we have SS total. Next, we have degree of freedom. We have A minus 1, A bracket N minus 1, and also A N minus 1. Mean square, we have MS treatment and MS error. Lastly is F naught, where it is equal to MS treatment over MS error. All right, so in the process of using ANOVA, first thing that we need to solve is SS total. Okay, so it start from here. Okay, SS total, and then it moves to SS treatment. Okay, once we find the SS total, we need to find SS treatment, and finally we get the SS error for the second column here. For next, what we need to do is we need to find degree of freedom for treatment, where we use the formula of A minus 1, followed by degree of freedom for error, and last one is degrees of freedom for total. Followed by MS treatment, mean square for treatment, and also mean square for error. Last one is the F naught. Okay, so we need to follow this sequence, okay? First one, SS total. Second one, SS treatment. Third one is SS error, followed by 4, 5, 6, 7, 8, 9. All right? So the one that we need to find is actually the F statistic, where the critical value for a significance level A and degrees of freedom V1 and V2 is given by F critical equal to F. Okay, this is alpha. This is A minus 1. A multiplied by N minus 1 equal to F alpha V1, V2, where this value, the F critical, actually we will find it using the F distribution table in the formula booklet. Okay, if F naught, or what we call it F statistic, okay, if F naught is greater than the value that we find using the F distribution table, so we will reject the H naught, the hypothesis null hypothesis. If F naught, okay, F naught that we find here is less than the F critical where we get from the distribution table, we can do not reject H null. Okay, do not reject H null. All right. So what are the formulas for all the values in the table? Okay, before that, what is n for? Okay, you see n here, right? N here. N is number of observation. Remember, in the introduction part that we have just now, n referring to number of observations. A is number of levels. Alpha here, okay, this is alpha, this is A, okay, it's different, okay, where alpha here is the probability of rejecting the null hypothesis H naught when it is actually true. All right, we continue with the computing part of ANOVA. Okay, just now we see from the table, we can see from the table that we have SS total. Remember, the first thing that we need to find is SS total. What is SS total? It measures the total variation in the data of our experiment. So the formula is given by this formula of SS total, the summation of Xij squared. Okay, what is I and J for? I is from 1 to A. A is the number of level, where J is equal to from 1 to up to N is number of observation, minus summation of Xij. Summation of Xij, you square it, okay, over number of level multiplied by number of observation. All right. Next is once we find the SS total, then we can find the sum of square due to treatment, SS treatment. Okay. So what is SS treatment for? SS treatment is measures the variation between the group means. It quantifies how much the group means differ from overall mean. So what is the formula? The formula is show here. Okay. Xij, the summation of Xij squared, okay, Xij squared minus the total of Xij, you square it, okay. This part you divide by number of observation, this part you divide by number of observation multiplied by number of level. Number 3, sum of squared errors, SS error. So how to find SS error? Now it's easy, okay? What you need to do is just take your SS total that you have here, sum of square total, minus SS treatment, so you will get SS error. Once you get these three, so you will complete the first column, the second column that you have here. Okay, the second column that you have here. For degrees of freedom, okay, degrees of freedom, you just need to use the value of number of level that you have, -1 for here, and substitute the number of levels and also number of observation for 5 and 6. And then we complete this the third column. So how to complete the number 7, 8, and 9? Okay, let's look at this formula again. Okay. All right. Number 7 is mean square for treatment. MS treatment represents the average variation between the treatment or group means. So what is the formula? The formula is SS treatment over A minus 1. Remember that you already found the SS treatment in the second column, right? Just use the value there over the value of A minus 1. This is the level of what we call it just now. We call it degrees of freedom. Okay, degrees of freedom. Just use the value there. All right. So next is MS error, or we call it error mean square. It measures the average variation within groups or treatment. The formula is MS error equal to SS error over A times N minus 1. We already found the SS error, right, in the previous step. So just substitute the value here, substitute the value of A and also N, and you will get the value of MS error. All right, number 9 is the one that we want to find actually, which is F statistic, where it compares the variance between group due to treatments to the variance within group, which is it is random error. So the formula is just take the MS treatment over MS error. Okay. All right. So before we could look at before we solve one example. Okay, let's learn on how to read the F critical from S distribution table. Okay, so how to find the value of F critical from F distribution table. Okay, example. Okay, example. For the value of alpha V1 and V2. V1 and V2 is the what we call that? Okay, what we call that? Okay, let's look at this table. Okay, it is degrees of freedom. Okay, alpha. Okay, alpha is the probability of rejecting the null hypothesis. Okay, so we will substitute the value of alpha, degrees of freedom in this F critical formula. Okay, and then we will refer to the F distribution table to find the value of F critical. Okay, let's say that in this example, we have um, the alpha value is 0.01, and then degrees of freedom 1 is 3, degrees of freedom 2 is 20. So how do we get 4.94 from the table, the F distribution table? Okay, you may refer to your, what we call that, formula booklet for statistic. You can check for percentage points F alpha V1, V2 of the F distribution. There are a few pages of it. You may check it. Okay. The first one is check the alpha value. If here alpha is 0.01, so you need to flip to this page until you find the value, the F distribution table for alpha 0.01. And then check the first V, which is 3. Okay, 3. So you find this is V1. Okay, you check 3. So the value of 3 here. And then check the value for V2. In this case, it's 20. So find 10, 20. So after we match it, we get 4.94. So the critical value when the alpha is 0.01, degrees of freedom 3 and 20 is 4.94. All right, now you understand, right? Okay, now let's look at the class example here. Okay, and see how to use ANOVA to do analysis. Okay, let's read it. A manufacturer of paper used for making grocery bags is interested in improving the tensile strength of the product. Product engineering thinks that tensile strength is a function of the hardwood concentration in the pulp and that the range of hardwood concentration of practical interest is between 5 and 20%. A team of engineers responsible for the study decides to investigate 4 levels of hardwood concentration. Remember, the word here levels. Okay, investigate 4 levels or 4 categories. So, directly we know that it is referring to alpha, number, sorry, not alpha, A, number of level, A, okay, number of level. So we have 5%, 10%, 15%, and 20%. They decide to make up 6 test specimen. What is it for? 6 tests. Okay, so it refers to number of observation. Okay, they decide to make up 6 test specimens, okay, at each concentration level using a pilot plan. All 24 specimens are tested on a laboratory tensile tester in random order as shown below. Test the hypothesis null that different hardwood concentration do not affect the mean tensile strength of the paper at alpha 0.01. So the probability is 0.01. So you are given with a table here where we have 6 observation and you have 4 level of hardwood concentration. So now what we need to do is we need to find the F critical, we need to find the F not, okay, then we need to compare these two, and we need to test whether the hypothesis null is correct or not. Okay, all right, remember just now we already defined that A is 4 from the information given and N is 6. Okay, so what is the first step? Okay, before that, let's list out the H null and also HA or H1 for this case. So H null is given as the hardwood concentration in the pulp does not affect, does not, okay? H null, normally we can see the word does not, do not, okay? Affect the mean strength of the paper. Second one is H1, the hardwood concentration, okay? It must opposite of our H null, okay? The hardwood concentration in the pulp significantly affect the mean strength of the paper. Okay, so originally we have the number of observation data and also the type of the level, okay, the levels of the hardwood concentration. So what we need to do is we need to add one more column to find the totals, the total of our observation for each of the level, okay, and then we find the summation of the totals that we have here. Okay, in this case, we add all these values, we get 60, 94, 102, 127, and the summation is 383. So this 383 is actually the summation of xij, which is equal to 3x3, right? 383. 383. Okay. Next is square table. Okay, square table, because remember we need to find the summation of xij squared just now. All right. So what we need to do is just square each of the value in the observation that we have here. 7 square, 8 square, 15 square. For all the level, okay, for all the level, find the square value. Once we found the square values, and then again we sum all the values, and the summation here that we got is actually the summation of xij squared. Alright, so here the value is 6625. Okay, again, I just want to repeat. First thing is copy the first table, the original table that you have, find the total. Next is you square all the values for each of the observation for each level, okay, and then find the summation. So here you will get xij squared. First one, you will get the summation of xij. Next step is, okay, we need to, okay, we already have all this information, all this for information. Now we need to find the SS total. Remember, the first thing we need to find the SS total. So SS total, the formula is summation of xij squared. Where's the value? 6625, right? Minus summation of xij bracket square. So the total of xij, which is 383, you square it, okay, over A is 4 and is 6. So just substitute, you'll get 512.96. Okay, remember, after SS total, what we need to do? Okay, we need to find SS treatment. Okay, how to do SS treatment? What is the formula? It is equal to 1 over n multiplied by summation of xij squared minus summation of xij bracket square over A times n. Okay, so n is 6, and then you take the value for each xij that you have in your table just now, okay? The original table, then we add one column, right? Okay, which is here, right? 60 squared, 94 squared, okay, up to the last one. Okay. Minus summation of xij. Okay, where is the value come from? This is 383 square over A times n. What is A? A is 4 and is 6. So once we calculate it, we get 382.79. Okay, now it's easy. Once we get these two, we can easily get the SS error, where it just what you need to do is just take the value of SS total minus the SS treatment. You get 130.17. Okay, now you already have these three values. Okay, these three values. Now find the degrees of freedom. Remember, to find the degrees of freedom is just take the value of A that you have. In this case, 4 level, right? Minus 1, you get 3. Second one is 4 level times the number of concentration, number of trials that you have is 6 minus 1, so you get 20 here. And then find the mean square. How to find the mean square? Take the sum of square over the degrees of freedom. So you get this value, 127.6. And also 130.17 over 20, you get 6.51. Okay. Once you get these three values, then your work become easy. All right. Last one. This is the value for F naught. Okay. This is actually F naught. Okay. F naught is MS MS treatment over MS error. So just take these two value, you divide, you get a value here. Now our task is to compare this value, okay, the F critical that you, the F statistic, okay, this is F statistic, F naught, and you need to compare with the um, F critical. Okay, remember how to find the F critical? F critical equal to here is alpha from the question that we have just now. Okay, from the example that we have, the problem, it mentioned that the, let's check again, the alpha is 0.01. The probability here is 0.01. So you just substitute here. Sorry. Okay, you just substitute here. And then the V1 is degree of freedom is 3. Degree of freedom number 2 is 20. Okay, from the example on how to look at the F distribution table, we already know that F at 0.01 and degree of freedom of 3 and 20 is 4.94. Okay, so we know that the F critical is 4.94. Now we need to check. Okay, we need to check. Yeah, sorry, the F critical is here. Okay, we already have the value here. Just substitute and refer to the table. And we need to compare the F critical and the F statistic that we have here. Which one is greater? If the F naught, the F statistic is 19.60 here that we have is greater than the F critical, in this case is 4.94. So we can reject the H null, which is in this case is correct, right? The F statistic is greater than the F critical. So we reject H null and conclude that hardwood concentration in the pulp significantly affects the mean strength of the paper. So that's the result. That's the analysis that done using ANOVA. Okay, until then, thank you everyone. That's all for ANOVA techniques to do statistic. Thank you. Assalamualaikum.